Good morning, students. This is Unit 2, Day 4. All right, it's time to multiply some polynomials and look at some different forms of these. So, without further ado, we're just going to get right in it. So, the first slide says which one doesn't belong. We can look here. I would probably accept a couple answers as far as if you wanted to convince me that A doesn't belong because it's already in factored form. I'm willing to listen. I'm also willing to listen to if you said D, if D doesn't belong, because it is to the third power, and the other ones are going to be to the second power if we multiply them out. I even would listen to B because we have a leading coefficient higher than 1. The other ones are going to have a leading coefficient of 1, so I would do B. So again, just having yourself looking at those and analyzing them in different areas. Okay. Rewriting in standard form. So let's review FOIL. Remember yesterday we did some solving the quadratics and factoring them out. Now we're going to reverse engineer that again, and we're going to FOIL. So x plus 3, x minus 5. Remember, first outside, inside, last. First outside, inside, last. So I do my first, and I do get x squared. I do my outside, and I get negative 5x. Okay, I do my inside, and I get 3x. And then I do my last, which is negative 15. Combine your like terms in the middle, and you're left with x squared minus 2x minus 15 as your answer. Okay, so that is using the FOIL method. We're going to build upon that today and build them even even bigger with bigger polynomials. So let's go back to our box. Okay, we learned that we can make a box from a piece of paper by cutting those in square sides from the links. We've got an 8.5 by 14-inch paper, and we see that. Identify the degree and the leading term of the polynomial. Okay, so that's going to be a little difficult, all right, because we now have 14 minus 2x, 8.5 minus 2x, and just x. So a couple things, all right. We know that the degree could be and would be 3 because, again, look, I have my 3 x's. We multiply those together. My degree is 3. Okay? Because if I multiplied this out, that's as high as it would go. Now, if we also want to say, what would the leading term be? Okay, we know that if I FOILed this, okay, yes, it's going to be backwards, all right, and I don't know off the top of my head what 14 and 8.5 is. Let me use my calculator. 14 times 8.5. We're going to get 119, okay, minus 28. X minus, we've got what would that be? 16, 17, x, and then plus 4, plus 4, x squared. So all that's going to look like this. Okay. Now, we can use distributive property and take that into each one. However, we just need to know what the leading coefficient is, and we know that there is a 4x squared and an x, which is going to give me a degree of 3 because I'm going to get a 4x cubed, right? So my leading coefficient, we'll call it my LC, would be the 4 of 4x cubed. Okay. So, without graphing, what can you say about the horizontal and vertical intercepts of this graph? Do these points make sense in this situation? Okay, so we know that the horizontal intercepts Okay, my x-intercepts are what makes this 0. Okay, so again, we'd be saying like, hey, 14 minus 2x equals 0. How do I do that? Okay, well, you would subtract 14. Negative 2x equals negative 14. Divide by negative 2. One of my x's is 7. Then when I come over here and I say, all right, 8.5 minus 2x equals 0. Subtract it over. So now I have negative 2x equals negative 8.5. Divide by negative 2. And you get you get a positive 4.25. Okay, so those are 2 zeros. We have one more, and remember that x is by itself. It's by itself right here. So when we say that, that's going to be a 0. Okay, that is going to be our 0. So that's how we find out when y is 0. Okay, when y is 0, x is at 7, 4.5, and 0. Why does that make sense? Because those would be the lengths of your cuts that would end up making it. Remember, that would be where my cuts are approaching each other, and if I cut it 7 inches, it's not going to do anything. Okay, I'm going to cut out that entire side, and I won't be having anything left to fold, and vice versa, the same with 4.5. Now, the 0, where does the 0 come into play? I got to have something to be a box. If I made a 0 cut, I still just have a flat sheet of paper. So I got to make some sort of cut. So that's why 0 is on there as well. Okay. Your vertical intercepts, that's going to be where you cross the y-axis. Okay, and you're going to cross it at 0 because you have to make x 0. Makes it pretty easy when we have a standalone x to figure that out. Okay, let's do some major distributive property. So we have 7x plus 2, okay, and then we have 4x squared minus 7x plus 7. We're going to use the distributive property in this example. It is the same as FOIL basically because you're taking this first term, and I come here, 7x times 4x squared. That is going to give me 28x cubed. Then I do here 7x and a negative 7x gives me negative 49x squared. And then I do my last ones here. 7x times 7 is 49x. Then I come inside. 2 times 4x squared, which is 8x squared. I have a 2 times a negative 7x, which gives me negative 14x. And then I have a 2 times a 7, which gives me 14. From here, we're going to write it in descending order and with common terms. So I look here, my highest degree is 3. So my final answer is going to start with 28x cubed. For me, I like to put a line through it when I'm done so I don't add anything extra. Now I've got a negative 49 and a positive 8, which is going to give me a negative 41x squared. And cross them out so we don't get caught up. Now I've got 49x and a negative 14x, which would give me a 35x. And then my last one, which is 14. Okay, so that is distributive property with a bi and a tri. Okay, now it's going to get really hairy, and we have a tri and a tri to give you a little brain freeze on this Wednesday morning. Okay, here we go. And again, take that 2 and distribute it to each of the 3 there. This is very tough. You got to make sure that you don't miss one. So I do my first terms here, and I get 16 into the 4th. I do my first and my middle, and I get a negative 2 in cubed. 2 in squared and a 3, 6 in squared. Okay, that 2 is done. Now I move to the 6. That's going to give me 48 n cubed. Okay? Then I'm going to go here, negative 6 n squared. Good? Here, 18 n. All right? 6n is done. Now I just take the negative 6 and I distribute it. Negative 6 times 8n squared, negative 48 n squared. All right, now I take it times negative n, and I get a positive 6n, and I have negative 6 and a 3 gives me a negative 18. Whew! Okay, that's a lot. Now we've got to pare it down. I look here. The degree of 4 is my highest, so I'm going to start with 16 into the 4th race. Now I'm going to look at, okay, how many cubes do I have? Well, here and here. I got 48n squared and a negative 2. Positive 46 n cubed. Now I come here and I see, okay, I got a 6n squared and a negative 6n squared. Well, those just go ahead and cancel each other out, and I'm still left with negative 48 n squared. Then I look here, okay, I've got, let's see, 2 n's, right? 18 and 6. Well, that's got to be 24 n. And then you got the negative 18 at the end. So, woohoo! We just did a try and a buy. I'm sorry, a try and a try. Okay, so there is that method that you could use. I'm also going to teach you the box method with this method as well. Okay, so we're going to make a box with 2 rows and 3 columns. Okay. Just like, that's too small, okay? It's too small. Let's get a little bit bigger box, shall we? Okay. So there we go. There's my box. Now, what we want to do is we want to take the terms, okay? If this is my my equation, x minus 8, we want to take that 2 term and put it here. Notice how I make this a negative 8. Okay, because we had the minus there on the 8. Then take your trinomial and put it on the top, across each column. So I got a 2x squared. Okay, I got a negative 8x, and I got a 6. From here, we multiply. 2x squared times 2, 2x cubed. I jump down, and this gives me a negative 16x squared. I come to this square, x and a negative 8x, negative 8x squared. I do the same here, and I get a positive 64x. 6x, negative 48. Okay. Now the cool thing about the box method again is that obviously we start with the 2x cubed, and then when I'm looking at my like pairs, I go in diagonals, kind of like this. So I got a negative 16, and a negative 8 gives me a negative 24x squared. I do this here, 64x and a positive 6x. That's going to give me 70x. And then I still have the negative 48. So the box method does kind of organize it a little bit so that it's easy for you to see if you're missing a term. Okay. Now, 1, 2, 3, 4, 5, 6. So let's do this. Let's go ahead and do another one. Now we are going to be doing our try and a try, which is always fun. Try to make this box nice and big so that you can see it. So it doesn't matter what you use, just take a try and write it on the sides. We've got a 7 n squared, we've got an n, and we've got a 3. I have a 4n squared, I've got a negative 5n and a 2. Again, guys, this is easy because I feel like it kind of just takes away that distributive property so that you are just good to do your free-flowing math facts. All you have to do is focus on those. You don't have to focus and make sure that you did hit everything, okay? So we're just moving through here. Again, it's the angle, so negative 5n squared. I got a negative 15n. Okay, 14n squared, 2n, and 6. So it does operate just like that. And again, I messed up here because, again, I forgot to put my n squared. So that would have caused a little confusion, but you just got to make sure that you get them all at the same time. And then again, we go and you see that rocking and rolling already, my diagonals. I start with the end of the fourth, that bad boy, and then I look here. Okay, negative 31 in cubed, because negative 35 plus 4 is negative 31. Then I go here. Okay, would have 14 and 12 give me 26. 26 minus 5 is 21. And there we go. Negative 15 and a 2 gives me negative 13n plus 6. Okay, so that would be how I would do the box method on that one. Difference of squares, okay? Difference of squares. We've got two cheats that we're going to learn here, okay? Two cheats. This is called difference of squares, and it looks like this. They have the same a and b, but the sign is different. So the form for that is this. So I've got a plus b, a minus b, okay? All we care about then is just a squared minus b squared. Because if we do the o and the I, this would be a positive 56. This would be a negative 56. They would cancel each other out. We just have to focus on the f and the l. So when we do that, we do get 64x squared minus 49. If that is difficult for you thinking, okay, I got to square it, just tell me, what's 8x times 8x? 64x squared. What's 7 times negative 7? Negative 49. So that's an easy way for me to see that I know what I'm doing there. Okay, now the next one is that I don't have this here. This is going to be the same. So if you've got 1, I'm sorry, that's a little in-your-face intense. When it looks like this, okay, you've got that a plus b squared. What always is going to happen is it's going to be a squared plus 2ab plus b squared. And if that makes 0 sense to you at all, cross this guy out and make it 7n plus 3. Okay, now they're back to back, and we just FOIL it out just like we knew normal. So the a is 7n. Square it. Okay, square it, and it's 49 n squared. By the way, see these scribbles? I'm only using pen because it's easier to see on the paper. I expect you to use pencil because it's more forgiving. Now I'm taking 2 times a times b. So we've got a 14 times 3, right? Because we've got 2 times 7, which is 14, and then 14 times 3 would be 42. Okay, 42 n. And then 3 times 3 is 9. And that would be how you would do the difference of squares. Okay. Okay, here we're going to be playing with a graph just a little bit. This A here, you can see the A out front. Okay, same graph. We see we're crossing at negative 3 and 2 and 7. Okay, whatever you say. Oh, the 7's right there. All right, I couldn't see it. So now when we add this A, you can see what happens when we go. There you go. So what this says is when A is 3, notice how my peaks, I'm stretching. Stretch, 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 stretch. Okay, so now look. I'm going to take it and I'm going to go to 2. Okay, let's look at our graph here. Okay, what you see is it goes and it almost doubles. Okay, so right here I'm at 48. Okay, I get clear to 48. Up here I get to 96. So if you double it, you're taking it times 2. And even more when you go times 3. Okay, times 3, we come up here and it's the same thing. See how it bumps up there. So that would be what the A does. So the A, if I have an A up front, stretches my graph. Okay. What degree do those polynomials have here? What degree is this? There's three binomials. So the degree is 3. So now we have this. Okay, I'm sorry. We'll keep going. Here, let's finish up. Here's your two graphs. Okay, it's telling us that f and g. Here's g. G is equal to k times f of x. So we see f of x is more pointy. Okay, we're wanting to know. We're wanting to know what the value of k is. Okay, so what did we multiply? What did we multiply this to get this? Does anybody know? We're taking it and we're shrinking it down. So I'm going from 5 to 1. Okay, so we could say that we're dividing that by 1/5. 1/5, okay, would be the answer. So the A on this equation, or g of x, is 1/5. Okay, and if we wanted to, if we could click on this and draw our zeros, that is what we would do, and you're going to get somewhere in those ranges, but 1/5 would be what you multiply. Okay, that being said, the homework today is in Canvas, and best of luck. Email me if you have any questions.